We hear it all the time, right? Trust the science. It's everywhere. But here's a thought. What if the most scientific thing you can possibly do is not to just trust, but to verify? That's what we're digging into today. We're going to look at how scientific claims actually earn their stripes and how you can go from just passively trusting to actively verifying what you see.
I mean, think about it. You already do this every single day. You go to a website, and what happens? It asks you to prove you're not a robot. It's this tiny little act of verification that we do without even blinking. We click a box, maybe pick out some traffic lights, and boom, we've proven who we are to a machine.
Okay, so that little digital check, that's easy. But what happens when the claim is a whole lot bigger? When it's not about getting onto a website, but it's about our health, our world, our future? How do you do that same critical check on a scientific study? How in the world do you verify science itself?
Well, that's exactly what we're going to lay out. We're going to walk through 5 key checkpoints, the gauntlet really, that any solid scientific claim has to get through. We'll start with the design and go all the way to the long, long road of scientific consensus. Let's jump in.
So that I'm not a robot check, we all know, it's a gatekeeper, right? It's the first basic hurdle. In science, you can bet the hurdles are way, way more demanding, but the idea is exactly the same. Before any claim gets taken seriously, it has to pass a whole series of tough tests. All right, on to our first major checkpoint, the design of the experiment itself. See, in science, verification doesn't kick in at the end when the flashy results come in. Nope, it starts right at the very beginning with the actual blueprint for the study. Because a weak foundation, well, it can't support a strong conclusion, no matter how exciting it sounds. So, what does a strong foundation actually look like? Well, instead of just an anecdote, this one thing happened to this one person, you want to see a randomized trial to cut down on bias. Instead of a study where everyone knows who's getting the real treatment, you're looking for one that's double-blind. That keeps people's expectations from messing with the results. And instead of no control group, you want what's called a sham-controlled group, basically a super scientific placebo to make sure the effects are legit. These aren't just fancy words. They are the absolute bedrock of a credible study.
And here's what that looks like in the wild. This definition is pulled straight from a study on vagus nerve stimulation. See how they spell it out? Both the investigators and participants were blinded. This is so important because it stops bias, whether it's conscious or not, from creeping in and tainting the results. It's a huge green checkmark when you're verifying a study's integrity.
Okay, so let's say a study is finished. Now it faces its next massive test, the peer review gauntlet. This is where a paper gets sent out to other experts in the exact same field, who are totally anonymous, and their job? To poke holes in it, to challenge it, find the flaws, and basically try to tear it apart to verify its methods and conclusions. It is a genuine trial by fire. And the process is pretty methodical. An author submits their work. An editor takes a first look to see if it's even in the right ballpark. Then it goes out to the peer reviewers, those anonymous experts. They send back all their notes and critiques, and based on what they say, the editor makes the final call. Accept it, send it back for a major overhaul, or just reject it completely. And trust me, a lot of papers do not make it through this stage.
So who are these gatekeepers, anyway? They're not some faceless algorithm. They are real scientists with serious expertise. I mean, look at this list. We've got folks from universities all over the planet, from Washington to Brazil. These are the people volunteering their time to put research under a microscope and make sure it meets the standards of good science.
Okay, so a paper makes it through peer review, it's published. Celebration, right? Well, the verification process is far from over. Now it's our turn. Every single published paper has a kind of paper trail, a DNA, if you will, and it's full of clues that tell you about its integrity. You just have to know where to look. Clue number 1, the conflict of interest statement. Right up front, authors have to declare if they have any financial skin in the game. This is a huge deal for transparency. It doesn't automatically mean the research is bad, but it is absolutely a piece of the puzzle you need to be aware of. And here is a very modern clue for you, the AI statement. With AI tools popping up everywhere, journals are now asking authors to be totally transparent about whether they use them. As you can see from these 2 examples, it's quickly becoming a standard thing to declare. It's just another layer of verification for the whole process. Next up is the ethics statement. Now this is a big one. For any research involving people, This is completely non-negotiable. It verifies that an independent ethics committee gave the study the green light and that every single participant knew what they were signing up for and gave their written consent. It's a check that makes sure science is being done responsibly.
And finally, keep an eye out for a data availability statement. This is a really powerful commitment to being open. By saying they'll make their data available, researchers are basically letting other scientists check their math by reanalyzing the original results. This is a true cornerstone of scientific verification.
Okay, on to our final checkpoint. And this one is less of a single gate and more of a long, winding road. The most important ideas in science, the ones that really stick, they aren't validated by just one paper. Getting published isn't the finish line. It's really just the start of a much bigger, longer conversation.
And this is maybe the most crucial takeaway of all. A single study, even a really, really good one, is just one data point. It's one piece of a giant puzzle. Real confidence, real trust is forged over time. It's built when other, independent labs can replicate the findings, through things called systematic reviews that pull together all the evidence, and through the constant tough debate that is the lifeblood of science.
And this just says it all, doesn't it? This is a standard disclaimer you'll find in tons of scientific papers. The publisher themselves, the people who printed it, are telling you flat out that they don't endorse the claims. It's this powerful final reminder that our job is to be critical thinkers, not just passive believers.
So there you have it. We've gone from a simple robot check all the way to the deep architecture of scientific verification. You now have the checklist. You look for a strong design, you know it's been through peer review, and you know how to read the paper's DNA for clues. The system isn't perfect, nothing is, but it is a framework built not for blind trust, but for rigorous, tough verification. Now you know the rules of the game. So the next time you see a big science headline, what will you verify?